I'm going to press the go live. Hello and welcome. Thank you very much for tuning in to another session of Streaming School. It's great to have you with us again, and we hope that everything we're providing is of use. We're really lucky now to go into a lesson with Mr. Sam Winch, and I believe today's maths, is it not, Sam?
It shows, yeah, we've got some enlargement, transformations, and recap of scatter graphs today.
Wonderful. Okay, great. Well, we have gone over, so the screen is yours, buddy, and let us know whenever you want to make any changes.
Brilliant, thank you very much. Yeah, as soon as you're ready, actually, Nish, you can share my screen. And yeah, we'll start off by recapping. So, as you can see on the screen, we spoke about on Monday scatter graphs, and we looked at interpreting scatter graphs. So, obviously, describing the relationship and pattern that you have on scatter graphs, and we were talking about positive or negative correlation, strong, weak, or moderate correlation, depending on where the plots are on your graph and how the graph looks. We looked at plotting scatter graphs. Then we looked at finding the interquartile set of data. So there you need to find the median number, as well as working out the lower quartile and upper quartile. And as you can see here on the screen, the lower quartile is, of course, the quarter set of data. So the first quarter of data, as well as the upper quartile, which is the 3/4 set of data, and the interquartile is the data in between that, the lower quartile and upper quartile. The line of best fit that we spoke about, where you draw the line, and it's an estimation. You try to hit as many of the points as possible. Doesn't have to start at the XY axes, but it has to go from the lowest point to the highest point if possible. Of course, missing out any irrelevant plots, so irrelevant points. So here you can see one that's on the graph that's away from the rest of the line. So that's the line of best fit, and we use that to estimate our answers. And then we briefly touched on transformations, but that's what we're going to go into more detail today. And as you can see, in terms of the lesson, we're looking at translation, rotation, reflection, and enlargement. However, before we do that, I'm just going to share my screen with you, and if I can maximize the screen actually, and we'll just look at finishing off something on an estimation, and that is answering some GCSE questions. So this is a past paper question. The first few are nice and straightforward, really. It says the scatter diagram shows the scores of 10 students in their oral and written exams. The question is, how many students scored 50 in their oral test? Well, here's the oral test, here's 50. So if we look straight up there, we've got 1 student, 2 students. And then if we can continue on by reading through this information, 4 more students take their same tests. The table shows their scores below. Plot the scores. So of course, we're just going to go 10 for oral. And if we go up to find 15 for written, and we just plot that like so on the graph. And again, if we go 94, which will be there. And we go all the way up to 90, which would be there, and we just plot that. So if I do one more example, we go 52. So again, we always use the x-axis first, 52, which would be there, and we go all the way up to 46, like so. And then finally, in fact, there's 2 more questions, and it says draw a line of best fit on the scatter diagram. So we can draw a line of best fit. Again, trying to hit as many points as possible. And again, it's an estimation with the plots as close to that line of best fit as possible. Now, again, if you look at it, we could say that that's positive correlation. And I would say that's strong positive correlation because of how close the plots are to the line of best fit. And then finally, one other question that was on the back said that Rob scored 40 in the oral test. He was absent for the written test. Use your line of best fit to estimate a score. So all we'll do there is if we look at 40 in terms of the oral test, which is here, and we're going to draw a straight line up, hit the line of best fit. If we go across from there, and we would get just over 40. So we're looking at 41 would be the answer here. Okay, so that's just, that was a 5-mark question that was taken from a past GCSE paper. If I can now minimize my screen and go back to today's topic. So we're looking at transformations. We're looking at rotation, which is the turn of a shape. Then we're looking at reflection, which is flipping a shape. translation, which is the movement of a shape, and they say sliding, up, down, right or left, and then resizing. So enlargement is the word that we use, but it is resizing because it might be increasing or it might be decreasing in size, okay? And enlargement is working at a grade 5 onwards, whereas rotation, reflection, translation falls around a grade 3. So you might find this on a high paper, but it would certainly be the first few questions, more likely than not. These 3 categories would be on a foundation paper, and enlargement would feature either at the back end of a foundation paper or near the front of a high paper. So the first one we're going to look at is translation. Now, what you need to know about translation is, as we've already said, it's the movement of a shape around a grid, and you use vectors to determine how you move that shape. So the first number on the vector would be determining whether it goes left or right. If it's a positive number, it goes right. If it's a negative number, it goes left. And the bottom number of the vector, or sorry, the bottom vector, would determine whether it goes up or down. Again, if it's positive, it goes up. If it's negative, it goes down. And here's another description. You've got the pink shape here and the blue shape here. Now it says that we go 11 spaces right, 11 squares right, and it goes 6 squares up, and that's where the new shape needs to be drawn, or that's how you describe the new shape. Okay, so you'd say, as it says here, 11 to the right and 6 up, or you could just write it in terms of its vectors, like that, open bracket 11, 6, and close bracket. And here you've got, this time we're going again from the pink to the right, you've got -2 and -5, so that means 2 to the left and 5 down. And what you could do is just find a point, any point on this triangle. If we look at this bottom left corner here, if we moved 2 to the left, as it says, and then 5 down, 1, 2, 3, 4, 5, and then you can just draw the triangle from there. But again, in terms of describing the movement of the describing the translation of the shape, you would just say -2 and -5. Okay, so if I can now share my screen. Here's a little worksheet for you that we're going to go through together on translation. And if I can just find my pen. So the first question here says, translate this shape by -2 and -5. And I've coloured them in with my black pen. So that says we want to go 2 to the left and 5 down. So I'm going to start off with this corner here, and then that will allow me to do the rest of the shape. So if I go 1, 2 to the left, 1, 2, 3, 4, 5, and just count that again, 1, 2, 3, 4, 5. So therefore that would be my corner shape there, and then I just copy the pattern out like so. Okay, and as you can see, I've moved 2 to the left and down 5. If we move on to this one here, it says we want to move 4 to the left and up 6 because it's positive. Now normally they're given them written as coordinates. You would often see it written like that, with one number on top of the other. But if it is written like that, just take that the first number is left or right and the second number is up or down. So -4 and 6. Again, we're going to use the top left-hand corner this time. We're going to go 1, 2, 3, 4, and then we go up 6. 1, 2, 3, 4, 5, 6. Just fitted it in nicely, and it's a T shape. So if we just colour them in like so. And the next 2 questions on translation is looking at describing the transformation or the translation. So here you've got a shape that I called A. It was grey, but we've changed it to A, and a shape onto B. So how does A get onto B? And if we again take this corner here, I want to see what the difference between that corner and that corner. So we've gone 1, 2, 3, 4, 5, 6, 7. So 7 would be the first number. And then we've gone from 7, we've gone 1, 2, 3, 4, 5. So we've gone +7 because we've gone to the right, and +5 because we've gone up 5. Again, if we were just to do A down here, use this bottom right hand corner, we've gone to the right again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's gone to the right 10, and then it's gone down from 10 1, 2, 3, 4. So because it's gone down 4, it's going to be -4. I hope you can just see that on the screen there. So that's translation. So moving a shape using your vectors. Remember, the top number is left or right, and the bottom number is up or down, depending on whether it's positive or negative. Looking now at reflection. So here you use the x-axis and the y-axis to reflect your shape. It says using a mirror line to move a shape. A line of symmetry is the imaginary line where you could fold the image and have both halves match exactly. So symmetry is really important in understanding the properties and principles of your shapes. So here you've got the example is x equals 4. So if we count across 4, 1, 2, 3, 4, there is our line x equals 4, and then we've just got to reflect our shape in that. So you just the shape doesn't change size at all. We're just, not for this particular question, we're just reflecting it in that line. So again, you've got some here. We start with h. Is then reflected in the in the x-axis, beg your pardon. And then the new shape here at the bottom right-hand corner is reflected in the y-axis. But again, it doesn't change size. It just stipulates reflecting it in both the x and y axes. So if I can share my sheet, perfect, like that. So it says reflect the shape in the x-axis. So we know that this is the x-axis. So I'm literally copying it down. There's no difference between, there's no spaces between the line. So I'm just going to, just copy the picture out. No change in size or anything like that. And in the y-axis, it's slightly different. There's a space between here, so I'm going to have to copy that, reflect that, and make sure it's reflected accurately by drawing the exact same picture, the exact same size in the y-axis. If we look over here, we've got the line y equals 2. So if we know that this is the y-axis, y equals 2 would be here. And if we can just draw our mirror line, so y equals 2. I don't know if that's very clear, but this is between these two dots here. That's my y-axis. So, sorry, that is y equals 2. So I'm just going to reflect my picture now. Instead of in the y-axis, I'm going to do y equals 2. So my first, there'll be a space there. So my first square will be coloured in there, and so on and so forth. And that would be y equals 2. If we go down to this bottom picture here, where it's y equals -1. So -1, of course, we're working down. This would be the line y equals -1. And again, I'm just going to draw my mirror line, which will make it a bit more obvious now, like so. And again, I'm just going to reflect it, not in the y-axis. I'm going to reflect it in the y equals -1 axis. So there's 2 spaces between, so 2 spaces here. And that would be my first one. Second one, let's go off the square a bit. Third one, and it looks something like that. So that's how to reflect your images in both the y and the x-axis. And now we're going to move on to enlargement. So yes, enlargement. So looking at shape A, it's enlarged into the next shape, shape A, and it's enlarged with the scale factor of 2. So the scale factor of 2 simply means it's been multiplied by 2. So everything within the shape has been doubled, both the height and the width. And also when we look at, and we will do shortly, when we look at the centre of enlargement, everything there is doubled as well. So from the point in which the image was drawn, it's been doubled. So the distance between, and we'll go into more detail shortly. As you can see here, if we use example A, the first compound shape is 2 by 2 in an L shape. B is 1, 2, 3, 4, 5, 6 by 6. Of course, the difference between 2 by 2 and 6 by 6 is 3. So B has been enlarged by scale factor 3. And then if we look at the triangle here, you've got again 2 by 3 this time, and you've got 4 by 6 this time. And again, the difference this time is scale factor 2 as opposed to scale factor 3. So A is scale factor 3, B is scale factor 2. And we can look at enlarge and of course resizing, so increasing and decreasing in size. But what I'm going to show you now is if you joined up the two exact corners in these two rectangles, and then we'll look at these two corners and two more corners, and if you draw lines throughout the shape, what you'll notice here is that all three lines will cross at some point, and at the point at which they cross, that is described as the center of enlargement. Okay, so that is the point in which the shape has been enlarged from. Now, obviously, we haven't got the axes put in here, but if it was to be that point there, then that's at which point we increase the size of the shape. So, in terms of scale factor 2 and 3, we know that that's to double it or to triple it in size. 1.5, of course, we're going to times it by a half, and it's going to increase ever so slightly. But if we looked at fractions or even decimals, then of course it's going to decrease in size. So if we were to increase it by a half, then it would decrease, of course, by a half. And 0.5 can be written instead of 1/2. So just be aware of, if you were to see a fraction, and here you've got this trapezium, if they wanted to enlarge that shape by a quarter, or they might write it as enlarge the scale factor 0.25, then we're going to divide it by 4, and that's the size of the shape. So for this trapezium here, it's got a height of 4 and a width of 8, 10, 12. So of course, if we're going to divide it by a quarter, it's going to then have a height of 1 and a width of 3. So it's going to be a much smaller trapezium. And in fact, you can see that here with the answers. You've got the height of 1 and the width of 3. So scale factor doesn't always have to be positive. It can be a fraction, it can be a negative number as well, and it can be a decimal to increase and decrease by size. And if we flick over to my screen here, if that's to say what I'll do, I will enlarge that. Perfect. So you've got enlarge the shape by a scale factor of 3. So we're looking to because it doesn't stipulate from where the center point is, we just need to make sure that we enlarge everything by 3. So it's 3 across, so therefore multiply that by 3 gives me 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's 1 either side, so therefore we're going to go 3 either side. Okay, so that's how to enlarge with scale factor of 3. Scale factor of 2, we're going to work from here. So it's got 4 there, 5, 6, 7, 8, and then we're going to go 2 across as opposed to 1 across. So that's going to double in size as opposed to just being 2 at the bottom. We're going to have 4. Now, in terms of the enlarging a shape by a scale factor through its center point. So the center point here is 1, 0. So we know that x-axis is 1, which is here, and 0 is still on the y-axis. So if I just put a dot there, that's at which the center point is. And that's at which point, if we call this shape A has been enlarged from. So that's shape A. So shape B is going to be moved, because it's scale factor 2. We're going to double shape A by 2. So the height is going to be 4, starting from there. So if we go 1, then we're going to go 2 away. So actually the first square for shape B would be over this shape, which is fine, that we can do that. And we're going to go 4 up, 2, 3, 4. And we're going to go across, it's 3 blocks across. So we're going to go 6 blocks across, of course. Okay, and then we might label that's B. So there's an example of how to enlarge your compound shape by scale factor of 2 through the center point of 1 and 0. But Nish, if you can share my screen, please. Yeah, so today we worked through transformations. We looked at enlargement, reflection, and translation. Friday we'll go with some rotation that we didn't manage to get through today. But you worked from a grade 3 up to grade 5 with enlargements, and we also just need to do some negative fractions of enlargements. So there's quite a lot to do still on transformations. But I hope you enjoyed today's lesson. Stay safe and have a good day.
Thanks a lot, buddy. Look after yourself.
You too, Leon. Take care.